jump to the second part. Now, the part that we will introduce is the concept of the layer 3 VPNs, okay? So, layer 3 VPNs. The idea is that it allows multiple customers to securely connect their remote networks over a shared service provider's IP backbone using layer 3 routing. Features. You can use, for instance, some technologies like MPLS, VLAN tags, and so on for performing the routing, the traffic aggregation and segregation, and so on. At each of the devices, the way to implement the layer 3 VPNs usually is by means of VRFs. VRFs are virtual routing and forwarding instances. So at the end, it's kind of having a virtual router inside the physical router. So you can, thanks to this, implement some form, let's say, of virtualization of your topology. So on top of the physical topology, you can have virtual topologies. Well, this is a bit tricky to explain. For what we need now, just keeping the concept that the VRF enabled to virtualize the router should be enough. And also this provides privacy and security without the need for encryption and some additional isolation levels. In terms of how it works, the idea is that the service provider routers, so the PE routers, are connected to the customer equipment routers. Like, for instance, in the case of data centers, it could be the data center gateway. Then the customer equipment routers advertise routes via dynamic routing protocols to the PEs, for instance, using the multi-protocol border gateway protocol. And thanks to this, the different elements in the transport network might know where is each of the customer equipments and networks.
Sorry.
Yeah.
I think we should use port 8080 to connect to web UI.
8080?
Yeah.
What do you mean?
In the previous slide.
Okay. Depends if you configure the virtual machine with forwarding to port 80 or port 8080. Yeah, in the HCVM it's 80 because we were checking that with Roger. In the virtual machine depends. If you have 8080 or 80, you can check it in the port forwarding. Yes, thanks for the point, Cheyenne. And what else? Well, and that's it. I mean, I don't want to spend a lot of time in layer 3 VPN theory because it's a huge topic. In terms of use cases, well, more or less what I was mentioning, you can use it to interconnect multiple cloud environments, maybe integrations, interconnection between office branches, whatever. Okay. Well, and here a few figures. So here, the idea will be that maybe you can assume that you have customer one that has a couple of sites, and you want to connect these two sites through this layer 3 VPN. Then at each of the PE equipment, you install a VRF, and then you let them advertise the routes and so on. If you have a second customer, then you can install a second VRF in the routers and configure them for sharing the routes for this secondary customer. Both of them, given that they are using different virtual routing functions, they don't interfere each other. Even they can have the same IP ranges if you want, but they will not collide because they are different VRFs. You can, well, this is additional examples, for instance, for high availability with primary and backup connections. These are use cases that are supported in layer 3 VPNs, even multi-homing cases, whatever. That looks quite complex, but let's simplify things, because here what we are interested on is just understanding that in our scenario we will have a couple of customer equipments that will be pre-configured. This is essentially what I was labeling as data centers in the scenario. Couple of provider equipments. These are the ones that will be managed by Teraflow. These are the COS routers in between. The part of BRF configuration and so on we will skip because it provides some additional level of complexity, and for the Hackfest we wanted to make it something simple and easy to follow. IP addresses, some of them are configured and others will be inferred by TerraFlow. So for instance, for the links between the data center and the router, the IP addresses are configured in the data centers, and the service that we will create, you will see that knows this information, but the part in between, this thing, will be inferred by TerraFlow. Okay, that's the idea. And instead of using BGP or whatever other dynamic routing protocol that might take quite a lot to explain, we will go for static routing that probably all of us knows how to work. And the target will be simple, being able to ping and maybe SSH between the two data centers. Okay, let's keep things simple. So for the service establishment, well, you have here the links for the example layer 3 VPN service descriptor that we will use. I have it here expanded, highlighting the placeholders that we need to fill in. So you see that a layer 3 VPN service contains first a VPN service description, which essentially contains for our interest the VPN identifier, and then it has a number of sites. In our case, we have 2 sites. For each site, well, we provide the identifier, we provide who is managing this site. In this case, it's provider managed. And also, well, details like locations, which devices are located over there, and so on. And then we have an interesting section that is the site network access, where we define the details on how to configure the connectivity at each of the points. I expand here this section on the site network access. This is for data center 1. You see that essentially what we are defining is, okay, I want to connect the interface ETH1 of data center 1 with the other one at the other side, but it's hidden here because the lack of space in the slide. We provide the addresses, so we specify the customer address is 192.168.1.10. This is what we described here in the picture. This is this one, the customer site, and this is the provider. It's 1.1 for the provider, so we go back here. Provider address 1.1, and the prefix length is 24. And then we can also define service details like the MTU, like the bandwidth, like for instance maximum latencies, and so on and so forth. Okay, so we can provide some form of quality of service profiles. Well, these are the addresses for the second site. I will skip because it's essentially symmetric with respect to the data center 1. And now what we will do is to create the connectivity service. So to do that, let me copy the command. I will go quickly over here in the interest of time. So let me connect here to the data folder inside the Hackfest. Then I will copy the command to create the connectivity service, paste, okay, and fingers crossed. Let's see if it works. First shot. Okay, if we get here an empty reply, things worked fine, because here what we are replying in this request is the list of errors. If there is no error, means things work. Then we can now go and check in the service tab of TerraFlow. One service was created, is our IETF layer 3 VPN service. It's a layer 3 service, as it's expected, connecting data center 1 to data center 2, and the service is active. If we go to the details, you see the endpoints, you see the details that were loaded from the request, and also here you can see the data that was taken from the service, like IP addresses, prefix lengths, and so on, and the path for the connection. So this was computed by TerraFlow in this case. Now, the next step will be, okay, let me go back here. Well, we already did this. I was showing you the details on the service. All this, it's what I was explaining, so you can check it back. And well, these are
Which is the service that listens on for the RESTconf? What is the? Is it part of the micro-KS exposing started services?
Which one you mean?
Then when you do the post command,
Yes.
you have a URL starting from the /RESTconf.
Yes.
Which service hears on this?
It's the NBI. The NBI, Northbound Interface. In Teraflow, we have a number of microservices. There is one of the microservices that is explicitly a northbound interface. This northbound interface essentially is a REST server that in different endpoints it exposes different data models. One of them is, for instance, this one, the IETF layer 3 VPN, and there are others for layer 2 VPN, for I don't know.
So is it that for every different, let's say, model of RESTconf you have a different anchor point, or everything is hanged from the same /RESTconf?
Everything, it's kind of a tree. So you start from RESTconf, and then inside the RESTconf, what you have first, let me go back to the...
So if it's, this is known to the others, then skip it.
Yeah, I mean, all the endpoints start with RESTconf data, and then the next thing that you have is the name of the model that you want. And from there on, it's just the specific branches inside the data model that you
So
want
the Teraflow SDN is that one that implements the RESTconf interface?
Exactly, it's implementing this. Okay, well, a couple of additional commands in case you want to check the details on the service, but this is not really important. I can show you, for instance, if you want to get the identifier of the service that was created here, I will paste. You will get the service, the 632 CF1. So you can check here that it was created 632 CF1. Okay, this is the identifier. So essentially, it's just retrieving this in order to check that the service was properly created. Okay, going back to the slide. Well, the last one on deleting the service, I will skip because otherwise we cannot continue with the next part. In terms of configuration, I was mentioning you that we have commands that we can use to check the internal configuration of the routers. That's what we will do right now. I will show you briefly the configuration of the routers just to see what was configured. So we connect. We are now connected to router 1. We enable in order to be elevated, and then show running configuration, for instance, and you can see here that interfaces were configured both for the Ethernet 10, that is the one facing to the data center, Ethernet 2 is facing to the other router, and also the additional route was created for this specific service that we were creating. If we go and check the other router, and we enable and show running configuration, it's symmetric. So ETH1 or Ethernet 1 is the one that is facing to the other, to router 1. ETH10 is facing to data center 2, and then we have the symmetric route in order to enable connectivity. Okay. Now, the next test to be done, well, this is what I was explaining. Next test to be done is, it's here. Yeah, I will start by testing the service first to check that it works properly. So I connect to data center 1. So if I check IP address, you see that I have IP address 192.168.1.10. Now that the service is up, I should be able to ping 2.10, which is the remote network. Okay, it is working fine. That's good. That means we have the service established between the two data centers. And, well, the other thing that I wanted to show you is that you can use also GNMI in order to interrogate the devices. If I'm not sure if GNMI is installed in the virtual machine. It should be. If not, you can install it with this command. This should take just a few seconds. But I will show you what you should get when you interrogate the devices through the GNMI. Okay? Because that way you see an example of GNMI payload. So I paste it. Oops, not here. This is the data center. So let me go to the root. I paste here. Okay. Okay, I got router 1 interfaces, and I will do the same for router 1 network instances. So that way you have a couple of examples. Paste. Okay, so I got the files from the SSH browser. You should be able to download the 2 files that we have generated. Download, we'll place them in downloads. Okay, now if I go to downloads, you see here I have the router 1 interfaces. I will open with the VS Code, and here you see that I have, for instance, for the path interfaces. Inside it has an interfaces data model that specifies for ETH2. Well, we have a lot of details. I will compact the parts that are not relevant for us. Here we have some metrics. That's interesting because it's related to the next part. So this is the place where you can check the metrics. We have subinterfaces, and in particular in subinterface 0 we can check the IP address, and we see that we have here the IP address that was configured by Teraflow for this specific interface, and it specifies that it's a static configuration. Okay, and it says that the neighbor is the other router, and so on. So this was discovered dynamically through some link layer discovery protocol. If we do the same for the network instances, you can see here the default network instance. I will skip all the details that we don't care about MPLS and so on. It says that it's using protocol directly connected and static, which is expected. And in particular in static, it has here for the remote network, the next hop is configured here. Okay, so it states if you want to reach this remote network, you have to go through this specific next hop. All this is OpenConfig standard things, so I will not spend a lot of time explaining all this. That's it. Test the service, we did it. And that leads me to the last part, that is on network monitoring. Okay, for network monitoring, the idea here is that we can use also the GNMI protocol for telemetry streaming. That means we can use the method subscribe, so that we provide as parameter the subscription request, and then we get a stream of subscription responses. Okay, the subscription request contains a list of subscriptions that we want to create, and for each of the subscriptions, you can define if you want it to work in streaming, in once or polling mode, different operational modes. We are interested in streaming. And for the subscriptions, you can define which is the subscription tape that you want. For instance, we can say a sample of this specific data, and then you provide the path. You say for the interfaces, maybe interface ETH1, I want to get samples every sample interval, and maybe do not suppress redundant samples, so you get each of them. Then when you issue this subscription, what you get is notifications that periodically provide the information. We will try this in a moment. For that, and remember, this is the part that I was mentioning is of interest for this part of monitoring, which are the counters per interface. So over here, I will copy this command. Over here, let's hope it works fine. So essentially this command will connect to router 1. It will open a subscription, to get information on interfaces ETH2 state. Okay. If I go here and I paste, then we are getting now samples. You see, for instance, here, this is the last sample, and this sample says that, for instance, there was 200K in octets, 1.5K in packets, and so on. And periodically, it is updated. And with every update, you get the samples that change. Okay. This is nice, okay, but the interesting thing is to collect all this data, process it, and display it in a usable way. So for that, what we can do is go to TerraFlow. We go to the Grafana dashboard. Here, credentials, it's admin and admin123 plus, and something strange happened. Why is not connecting? Am I doing something wrong? Admin123 plus. Wait. Okay. For some reason it was not properly configured, the new password. Oh. The password and the dashboards were not properly configured. Okay. That's boring. It looks like my TerraFlow deployment at some point crashed during the coffee break and it deconfigured in the Grafana dashboard. Interesting. Okay, the part of monitoring it's not working here. That's boring. Well, let me try to if I redeploy. Well, anyway, I will show you in the interest of time because we are running out of time. I will jump to the slides and maybe you can see some of the videos where we have it running. The idea is that whenever you open the Grafana dashboard, you get some plot like this, okay, where you can see, where is the, okay, like this pointer. You get some plot like this one, where you have on the x-axis the time, and you have a couple of y-axis. One of them is the packets per second, the other is the bytes per second. What you should see is that here in the list you have for each specific interface the legend with the summary of values, and then while the experiment is running, you see that there is just some few packets in background that are used to check that the link is active between the routers. But when you start the ping, what you should get is that you get approximately what ping generates, that is approximately 1 packet per second and around 100 and something bytes per second. But for some reason, Grafana dashboard was not working properly. If we have time later, I will try to redeploy and show you. But for now, let me finish this. Well, too easy note, because at the end we had a number of issues. But in case you want to continue playing with this and with TerraFlow, I propose you, for instance, you can extend the scenario with some additional routers or clients. Maybe you can try to measure the performance with iPerf or something. You can try to create parallel services, and for sure you can always browse the issue browser of TerraFlow here, where if it opens, you have a lot of issues that are open and we are addressing in the community. And well, if you find some of the issues that it's of your interest and you want to contribute, feel free to contact us, and we can see how we can assign one to you maybe, and provide some support. And well, that's more or less what I had prepared for this Hackfest. Some of the topics that are hot on the TFS community. Well, you have here some of a list of some of the demonstrations that we ran in the past. As you see, some of them include things like integration between open source Mano and Teraflow SDN. Others include transport network slices and SLAs, slice grouping, hierarchical deployments of Teraflow in order to manage multiple domains. Many things related to anomaly detection, DLT-based end-to-end inter-domain connectivity, the use of Teraflow as optical SDN controller, and so on and so forth. I mean, there are a number of them. All these, it's mainly supported by research projects from the European community, which is very good, because that means Teraflow serves as a central point for sharing the progresses and the contributions from these research projects. And well, towards the release 5 of Teraflow, things that we are envisioning to integrate include, for instance, inventory management, intent-based networking, network digital twins, energy optimization, international data spaces, and so on. So that's what we have in mind. And well, in terms of contributing and joining Teraflow, this is more or less what Sylvia was presenting at the very beginning. This is just a recap. So if you are interested, you need to find, well, probably the best option is to contact Sylvia, and she will provide the best advice, or Sylvia or Roger, because they are the experts. Well, I will not repeat myself for this. Stay tuned, and well, this is more or less the wrap up. And I don't know how we are in terms of time. Yeah. Half an hour. If you want, we can try to redeploy now Teraflow and see if we succeed repeating this thing of the monitoring, at least to show you how it runs in real time. I don't know which one is the one that was causing problem, so I destroyed the Teraflow environment. The next thing I will do is redeploy Teraflow. Let's see if I succeed to make it work. Hackfest 5 and redeploy Teraflow. In theory, this time it should run faster because the components were built beforehand, and if nothing changed, the different layers of the Docker images that compose the services should be cached. So let's see if we succeed, and I can show you the overall thing. Okay. Yeah, question?
Is it possible to explain how we can add a database from Teraflow SDN to Grafana?
Yes. The idea is that right now in Teraflow, well, in this version of Teraflow that I'm showing here, what we are using is QuestDB for the telemetry data, for the time series database. This database, behind the scenes, exposes the data in the form of an SQL database. So if you can integrate the database in Grafana, for instance, as you will do for a PostgreSQL. So if you know or you have an example of integrating a PostgreSQL, then you are done.
And what is the URL when we want to add the database? We should write a URL inside the Grafana. What is the URL and port?
Yeah, let me let me go to the TerraFlow controller. Well, this is a bit of coding, but I think given that we have few minutes while TerraFlow deploys, here in the tfs.sh script, well, this is the core of the deployment of TerraFlow. It has a number of stages. Here at this point starts the automatic steps. The first part is on preparing some secrets and so on. Then there is another part that is on building the components and deploying them. Okay. This is a bit long. Then we deploy some extra manifests that include things like, for instance, service exposition, service monitoring, performance of the services, and so on. The last part that is over here is whenever you specify that you want to deploy monitoring and the web UI, it activates the configuration of the web UI data stores and dashboards. In particular, and I think this is the step where we had trouble the previous time, what happens here is that Grafana is configured with the password that is given in the settings of TerraFlow. This is the default one for Grafana. Yeah, but the point is that for some reason Grafana, I think, or crashed or had no enough resources or something happened, and maybe this step was lost or failed. I don't know. We will check. Then it installs some additional plugins, and here at this stage, what it does is, by means of curl post, we create the data stores. So here you see that we are providing as URL the QuestDB host port, direct host port. Where is over here? So it's essentially the host name semicolon the port, the SQL port of the QuestDB. So it's just like this. Then you provide here the name of the database that you want to connect to, the username, and at the bottom you have the credentials, that is the password. Then with this thing, you apply this, you execute this command, and it creates the data store. And well, we are creating a couple of them because we have a number of dashboards. You will see if it works, which ones we have. Okay, at least it says it was deployed, and in principle here it says that the admin password was changed. In principle the different dashboards seems to be created properly, and the data sources. Okay, and now it says it's done. Let me now deploy Hackfest 5 CLab deploy. Let's deploy it, and while it deploys, I show you the Grafana dashboard, how it should be. Oops. Okay, funny. Now it's crashing. Because a huge load due to deploying Container Lab. Okay. Next time we have to consider using, instead of virtual machines with VirtualBox, maybe a cluster, because I think we reached the limit of the laptops and the virtual machines. But yeah, for the next time I will discuss with Roger and probably deploy things directly in the Etsy bin. Okay, now that the load is reducing a bit, let me see if I can open the web UI. This is the old one. Okay, let's see if this finishes. Okay, in theory, now it's done. Now I think we are reaching the limit of the virtual machine. No, I think it should be in this one, but why not? No, no, it's in this case it was 80. Okay, now we have this, but I presume it redeployed the web UI component and Grafana. We will see. If admin123 plus works, no, it probably restarted the Grafana dashboard due to the lack of resources while deploying the container lab. Maybe we can do it the reverse way. If I deploy first container lab, I already have it, and then I redeploy TerraFlow, it will work, maybe. But clearly for the next Hackfest we go for virtual machines in the HCVM with more resources. Luckily now it's deploying relatively fast. Let's see if we can see at least this last part in these few minutes. Now it's configuring the dashboard. Okay. Well, it creates a connection. I can try to show this. Again. Admin 1, 2, 3. Okay, now it worked. This is the Grafana dashboard. We have, as I said, a number of panels. The one that I'm interested in is the layer 3 monitoring. Right now it has no data, but if we try to connect to Teraflow Web UI, and when, okay, now it finished the deployment. Now I will onboard again the devices, submit. Okay, so we got the topology onboarded. Okay, we have it. Devices, we have the devices. If we check layer 3 monitoring, you see we started to receive the, let me reduce a bit the zoom. We started to get the samples here. Right now there is no traffic, so essentially what we get is 0. Then what we will do is to configure the service. If I find it, it's this one. Wait, I have to go to the Hackfest 5 data, and then we post the service. Hopefully it will work. Okay, principally it was created here in the service tab. It is active, and you see now when we created the service it started to work. Finally. Okay, and now if we connect to the CLAB, for instance, CLI data center 1, and we do something like ping 168.2.10. Now we have traffic. What we should see is that in few seconds we start getting the sustained peak at more or less 1 packet per second and something like 100 bytes per second. Let's see. Well, now you see it's reaching the 1 and this 100. And if we stop, maybe we can try to SSH, I don't know, the other side. I don't know which user will be using, root probably, at 192, 168, 2.10. No, it's not permitting it has no SSH. But well, that will be more or less the idea. At least you get the point. And when the traffic stops, then the plot goes down. And well, more or less that's the idea. Finally, at least we made it work. I don't know if it worked on your side, if you had the chance to try this last step. Any of you? Well, then I think that's all, also because we are reaching the top of the hour. So I don't know if there is some last minute question, something you would like to raise. Otherwise, maybe we can close the session here. Maybe we give some time for the participants if they want to fill in the surveys and so on. And luckily we will reach the dinner on time. So thank you very much. And well, even with a lot of trouble during the session, I hope you enjoyed the Hackfest. Thank you.